Oh, yeah, Auntie was asking, can electrostatic shielding be a characteristic or no? Oh, okay. Miss, you're not recording.
Auntie, I do not understand the first one, the electric potential. Constant is zero, but auntie, why did you bring in the minus dV by dr here? Auntie, no. Auntie, but I'm confused. Like I don't understand. Auntie, like it's field between field and potential. What is R here? Oh, okay, auntie. Sorry, my bad. Auntie, I got confused. It's okay.
Fusion. Chal. So V is equal to KQ by R.
Auntie, no, I have a reference with me, and I'm like using both to study like my reference and what you're
None
teaching
of the
at the
reference would have
experiment
used
one.
any other alphabet other than R.
Auntie,
They
they've used X, so it's confusing.
they wrote V is equal to KQ by X.
Auntie, बहुत जगह पे they've used X in the denominator, so it's like
No,
confusing.
I'm asking you a question. Have they written V is equal to KQ by X?
Don't know.
Thank you very much. This shows how good your preparation has been in all through 7-8 months, isn't it, children? पारस ने बोल दिया तो ये बाहर आ गया. I don't know how many of you are sitting in that status. V is equal to K, equipotential surfaces. What are equipotential surfaces? Surfaces on which the potential is going to remain a constant. So for a point charge, sorry, I don't know what's the issue with my system. Yes, for a point charge, this equipotential surface is spherical in nature. Is that clear? Whereas if it is going to be a uniform field, if it is a uniform field, the equipotential surfaces are going to be planar. They are going to be planes that are going to be equidistant from each other and perpendicular to the field. For example, if this is going to be the field, this is going to be the equipotential surfaces. Whereas for point charge, the equipotential surface is going to be spherical in nature. And for dipoles or for dual charges, for example, I have a positive and a negative charge, then the equipotential surfaces are going to be denser in between and rarer further away. Whereas if it is going to be like charges, they are going to be rarer in between and denser further away. So that means this shows repulsive field and this shows attractive field, and they are going to be ellipsoids and not spheres. And with respect to equipotential surfaces, we are going to say that the electric field, we know that they are radially outward for a positive field and radially inward for a negative field. And because the equipotential surfaces are going to be spheres, the electric field is always normal to any point on the equipotential surface. इधर भी equipotential surface का कोई भी point लिया, so you can see that they are perpendicular to the field, and equipotential surface spherical हो तब भी तुम्हारा electric field is going to be perpendicular to the surface, perpendicular to the point on the surface. इसका जस्टिफिकेशन तुझे जरूर पढ़ना चाहिए. Why is the electric field normal to the equipotential surface? Why is electric field normal to the equipotential surface? ये करना बहुत जरूरी है. You have to do this. This is a very commonly repeated conceptual question. Is that clear to all of us? Are you hearing me, children? So for an isolated charge spherical है, तो tangential के लिए electric field perpendicular है. For a uniform field, it is going to be planar. So what is the inference of this? इसका inference क्या है? इसका inference ये है कि work done on an equipotential surface is always equal to 0. Is that clear? Work done on an equipotential surface is always 0. आप सुन रहे हो मेरी बात? Are you hearing me, children? So why is the electric field normal? अगर electric field normal नहीं होता, tangentially there will be an electric field. So if this is the electric field and if this was not the electric field, suppose it is inclined at an angle, then you resolve it into two components. The perpendicular component will not do any work because sin 90 0 हो जाएगा, but the horizontal component will do some work. So that means on an equipotential surface you have to work to move a charge which is against V is equal to W by Q, where V is nothing but V1 minus V2. So, but since V1 is equal to V2, W has to be 0. But in this case, W is not 0 if the electric field is going to be inclined at a particular angle. So, it cannot happen. Work cannot be anything other than 0. So, therefore, electric field has to be normal to any point on the equipotential surface. Is that clear to all of us? Just give me a yes in the chat box, please. Do you understand the concept? Now comes the next part where we are going to have what Pranavi said, the density. It is the density of the equipotential surfaces. So what do they tell us about it? Again, the density of the equipotential surface, because E is equal to minus dV by dr. Greater the separation between the equipotential surfaces, lesser the field, because it is the negative potential gradient. So the other character or the other concept that we have to talk about is the strength of the strength of the electric field with respect to the, I hope this is what you meant, Pranavi, with respect to the density of the surfaces. Can you
Yes.
confirm? Yes, right. So because E is equal to minus dV by dr, I can rearrange this and say dr is equal to minus dV by E. So that means the separation between the potential surfaces is inversely proportional to the field. And we know that the field is inversely proportional to the square of the distance from the charge. So the further you go, the field weakens, and the more the field weakens, the separation between the equipotential surfaces increases. Is that clear? And here again is where what Pranavi said comes. No two equipotential surfaces, no two equipotential surfaces intersect with each other. They cannot intersect with each other, because if two equipotential surfaces are going to intersect, assuming that they are going to intersect, at the point of intersection, we will have two values for the electric potential, which is not possible at a given point in an electric field. There can be only one electrostatic potential. So that means this is not possible for them to intersect. This is how you are going to go ahead with the characteristics and with the concept based questions that might come out. So what is electrostatic potential? The definition of electrostatic potential W by Q, the derivation of electrostatic potential, and the graphical analysis of the relationship between electrostatic potential and field with respect to the distance from the charge, and again the numerical relationship, scalar quantities, superposition is for numerical, and the characteristics of electrostatic potential and equipotential surfaces. Now I would like you to do a numerical based on this, assuming that I have a um, you know charges that are going to be placed. Let's pick up a particular numerical. I'm going to open up over here. Okay, right. Chalo. So there are three charges here. There are point P, I pick a point Q here, and I pick a point R here. Now I have minus Q here, I have plus Q, capital Q here, and a minus Q. These two are minus q and बीच में plus q रख दिया है at equal distances. This whole distance is 2a. So these two distances are equal. Q is placed exactly at the midpoint. Is that clear? Right? Now the system is in equilibrium. If the system is in equilibrium, find the ratio of capital Q is to small q. How are we going to do this? The system is in equilibrium. Then what will be the ratio of capital Q is to small q? Let's try this out, please. Kondama. Are we so are we solving? What is the condition that you will? The ratio that I want you to find is written on the board, Gautam. Ratio of capital Q is to small q. What is the meaning of the system is in equilibrium? May I know? Anybody in the chat box, what is the principle that you will apply when I say that the system is in equilibrium? Is E1 is equal to E2, Mayank? Can E1 be equal to E2? Think about it. The forces will be the same. Thank you very much. The force experienced at any point is going to be zero. Yes or no, children? If the system if the system is in equilibrium, that means there is no movement, there is no the charges are where they are. So if the system is in equilibrium, the net force at any point is zero. The net force on any charge is zero. Yes or no? So I'm going to find out the force at R due to P and the force at R due to Q, and I'm going to equate it to zero. That is, I'm finding out the net charge at R, net force at R. Chalo, now that I have given you the hint, aap solve karo. You know what is the formula? 1:4. I don't know, Sanya. Honestly, because
Auntie, we won't be considering P into the picture.
we won't be considering what in the picture.
P.
यहाँ पे लिखा है ना RP.
Okay. So RP and RP. Okay, I got it.
Correct. Sanya, you used the same principle or you used a different principle?
Auntie, same.
Same principle, right? Okay.
I just equated FPQ is equal to FPR.
Okay. Okay, Mayank also says it is 1:4. So, okay, you picked the PQ and QR, is it?
No, PQ and PR.
Okay, PQ and PR. Okay. And that is what, okay. PQ and PR, I am picking RQ and RP. Okay, both are one and the same. Okay, Dhruv also gets 1:4. So let us proceed to solve it. FRP, that is going to be K into Q into Q divided by 2R the whole square. Right, children? And this is going to be repulsive minus, because this is going to be an attractive force that is between R and Q, which is KQQ by R the whole square is equal to 0. K कटेगा, एक Q कटेगा, R square will also get cut. So what do I have here? Q by 4 is equal to capital Q. So this implies Q by Q is equal to 1 by 4. So the ratio is 1:4. Yes, that's right. I hope the others also got 1:4 for this answer. Vedant Vadalikar also gets 1:4. So that is correct. So this I gave on the basis of force equilibrium, which is our previous case. Let's do another one now. There are 2 point charges. I'm having a point A here, B here. There are 2 point charges. One is 5 nanocoulomb and the other is 3 nanocoulomb. They are going to be placed at a distance of 6 centimeter apart. Okay. So what is the work done in moving the charge from B to 1 centimeter towards? So this point is C they have taken, and this distance they have taken as 1 centimeter. They are asking what is going to be the work done in moving it towards C. Chaliye, what is the work done? Can you write to me what is the formula that you will write for work done from what we have discussed so far? V is equal to W by Q. So W becomes equal to V into Q. What is this V into Q? वर्क डन कैसे वोल्ट में आ सकता है बोलो सान्या. Absolutely right, Mayank. This is nothing but
We found
change.
the potential.
Yeah, what you found is the potential and it has to be in joule. So this is nothing but the potential energy of the system. Work done is nothing but potential energy of the system, and U is equal to, we know it is KQ. So this becomes KQ1 Q2 by R. Potential energy of the system मैं यहाँ पे I am putting it up here. So that is going to be KQ1 Q2 by R. Right, children? So the work done in moving from B to C is going to be equal to the potential at B minus the potential at A. Yes or no? I'm sorry, at C. Correct? Change in potential energy is equal to final potential energy minus initial potential energy. So what is going to be the final potential energy? That is K into Q1, Q2 by the final distance is 5 centimeter minus K into Q1, Q2 divided by the initial distance is 6 centimeter. So can we proceed and give me the answer in the chat box, please? Q1, Q2 is constant, K is constant.
And we are calculating for AC, or are we calculating AB? Because like Auntie sees the point where we have to reach, right?
Correct, beta.
Okay. Auntie, I thought that we are calculating force at C. Sorry.
Okay. Shiva, I'm not recording Shiva. So KQ1, Q2 into 1 by 5 minus 1 by 6. यहाँ पे 10 power minus 2 बाहर निकाल देती हूँ. Now you start substituting. K is 9 into 10 power 9 into 10 power 2 into 5 threes are 15 into 10 power minus 18 into 1 by 30. So I have 15 twos are. So एक 10 power 9 के लिए ये minus 9 बनेगा और ये बनेगा 4.5. So 4.5 into 10 raised to the power minus 7 joule. Is this the answer that you are getting? Where is the 10 power minus 7, Sanya? How could you get 4.5 joule?
Auntie, I forgot to take the 10 power minus 9 for the other charge.
Very well done. Yeah, 1 by 5 minus 1 by 6 is 1 by 13, Mayank? Angie, some of us are neither interacting in the chat box nor sending me any answer. No yes or no, nothing in the chat box. Okay. Chal. So let's move on now. So now comes our concept of U is equal to K Q1 Q2 by R. So this is going to be for a two charge system. So suppose if I am going to have three charge, please understand that this is the work done to assemble the charges. To assemble the charges in a given configuration. Whereas what is going to happen if you are going to dissociate, this will be U. If it will be negative U, that will be the work done to disintegrate the system. Disintegrate the system, then it will be negative. That means this is from infinity to a point, and this is from a point to infinity. I hope you are getting this clearly, isn't it, children? Right, children of grade 12? So this is for a two charge system. There is only one, that is Q1, Q2 by R. If it is going to be a three charge system, this is R12, the distance between the first charge and the second charge. So this will be Q1, Q2 by R12 plus Q2, Q3 by R23 plus Q1, Q3 by R13. I hope you understand this. This is going to be for a three charge system where you are going to find out what is going to be the work done. It will be three different work done for you. Hi, Anna.
Yes, auntie.
Yes, so it is going to be this. What is going to be the work done in bringing a third charge when you are going to already have two charges that are present in the system? Is that clear? Right? We could do
Auntie,
this.
can they ask us
Okay.
force experience at a point between two charges?
Why not? Force experienced at a point in between two charges.
Yeah.
इन बिटवीन टू चार्जेस फोर्स एक्सपीरियंस कैसे आएगा? फोर्स एक्सपीरियंस करने के लिए जिस पॉइंट पे तुझे फोर्स एक्सपीरियंस करना है उस पॉइंट पे चार्ज होना जरूरी है ना.
Oh, yes, auntie.
That is when you can apply Q1 Q2 by R square, because according to Coulomb's law F is equal to K Q1 Q2 by R square में R is the distance between the two charges. So I
Yes,
cannot
auntie. That is
place
what I
a
was
charge here.
asking.
I cannot place a charge here and say I want the force here. यहाँ पे क्या रखोगे फिर? Field you can find out. You can find the field at this point. You can find the potential at that point. You cannot find the force at that point.
Understood, auntie.
Yeah, you can find E and B but not F, because F के लिए वहां पे at least you should place a unit positive charge over there and then you say that is the force. Again, then you will write it as, the value of the charge has to be put in and substituted over there. Is that clear?
Yes, auntie.
Okay, please do not convert into decimals. Try to keep your calculations as simple as possible. Is that clear to all of us? Right, now let's do one numerical based on this. There is a three charges. Each charge is given by 3 into 10 raised to the power minus 7 coulomb. If these three charges are to be brought from infinity and placed at the vertices of an equilateral triangle of side 30 centimeter, how much work will you do? Chaliye, the question is as simple as this. There are three charges. Each of each दे दूंगी तो काफी simple हो जाएगा, सारे common हो जाएंगे. Let me change it slightly from this sum. Let us say I make it plus 2q here and a minus q here and a plus q here. Chalo, let's do this. I'm not giving all q at the vertices. These are the charges that are going to be brought to the vertices of an equilateral triangle. What will be the work done? I have already given you the formula. By now you should start working on this. Chaliye. And let me see honestly chat box में कितने answers आ रहे हैं. हाँ जी. So work done is nothing but the potential energy of the system, and I said bringing it from infinity to the point, that means it is going to be positive k, and सारे r same होंगे because all the distance between them is 30 centimeter. and this is potential energy, which is a scalar quantity. So the first will be minus q square, and I have a minus 2q square plus 2q square. This is going to be the value. No, you are going to substitute q का value दिया है मैंने. So you are going to substitute the value. Sanya, you can't give me a value like this. So this is
Right.
k by r. So this is minus 3q square. So this will be minus q square. This is how you should proceed, children. Don't waste your time substituting right from the beginning. Now k is 9 into 10 power 9. This is 30 into 10 power minus 2, and negative of 9 into 10 raised to the power minus 14. So this is how you are going to do. No, Gautam, I have given the value of Q. So please substitute the value of Q. So 3 goes 3 times here. I don't know how you got a 90, Mayank.
You didn't square the denominator.
Why will I square the denominator? It is potential energy. It is not force
Oh,
or
right,
field.
right. Sorry,
Force
I'm
or
wrong.
field is r square. How are you people getting 6 and all? I don't understand. Hanji?
Auntie Sunny, Auntie, instead of like minus q square, I just took it as minus q. That's how.
Very well done. So this is 11. So 10 power minus 3 joule. Yes, Pranavi, you are getting a minus 4. I am getting a, oh, yes, yes, yes. My bad, Pranavi. The 30 I did not see. Sorry, sorry. So this will be 10 power minus 4. Yes, my child. There is a 30 here. I missed out. So minus 27 into 10 raised to the power minus 4 joule will be the potential energy of the system. Yes, Dhruv, that is correct. I do not know how many else are solving, right? It is the same names that come up in the chat box, right? Mayank, Gautam, Satvika, Shiva, Pranavi, Dhruv, now Vedant. That's it. Paras. I don't see any other names. Ronak, Vardhan, Harmil, Ananya, Manya, Mansha. What are we doing? Pranjal. Anji, I don't know what's happening in the online class. What are we all doing? All these names that I picked up. You used the force formula. Okay. What about the others? You are still solving. Okay. And you got the answer. Okay. What about others? You are solving, Manya. Okay. इतने सारे नाम जो मैंने लिए हैं उसमें से 3 बंदों ने चैट बॉक्स में आंसर दिया, बाकी बच्चे तो सो रहे हैं. फिर अभी तक ये नहीं सॉल्व हुआ, कैसे सॉल्व नहीं होगा? हाँ जी.
Yeah, Auntie, I got this. Auntie, I was doing.
What is so difficult in this calculation? Right, children? I don't know, honestly. I'm extremely not happy. I will see ना थर्सडे को जब आके लिखोगे आप लोग पेपर, तब मुझे पता चलेगा ना कि कितना किया है आपने. So I'm going to pick up another sum where let us pick it up. We'll do some kind of vector algebra. Shiva, bolo.
Ma'am, can you go back to the previous page? Like
Yes,
the
please.
sum. Ma'am, so like we are finding potential energy for the entire system, right?
Correct.
So, uh, ma'am, how did you get minus 2q square? Like plus
What is
2q
this
square is there.
into this?
Okay, okay. I got it, ma'am.
And in potential, you have to introduce the sign, na Shiva?
Yes, ma'am, yes, ma'am.
Right. So let us consider, I'm going to pick up a square. Okay. There is a square here. And at the end of each vertex, let's see what are the charges that they are placing. They are placing here 3 into 10 power minus 8. And then they are placing minus 3 into 10 power minus 8. And then they have a minus 5 into 10 power minus 8. And oh my god. and 6 into 10 power minus 8 coulomb. Okay, these are the charges placed at the vertices of a square and the square ka side 1 meter. Is that clear? Find the potential at the point of intersection of its diagonals. Chaliye, let's do this. Find the potential. This is CBSE board question, children. This please. Oh, the point of intersection of the diagonal pe find the potential. Potential at O. So remember, you are going to just simply calculate the sum of the potentials at O due to the 4 points. So let us see for this question how smartly you are going to approach it and how easily and fast you are going to get the answer. Let's do it. All right. Got it, children? I hope you would have started substituting by now. So the potential at O is going to be K by, if I'm going to name it as O, A, B, C, D. O is equidistant from all of them, so I'm going to consider it as O. And I know the potential at any point is K, Q by R. So that's it. K by OA अगर मैंने बाहर ले लिया, so it is simply Q1 plus Q2 plus Q3 plus Q4. That's it. I hope you went on to calculate this smart. Now K becomes 9 into 10 power 9. For a 1 meter square, the half of the radius is going to be, half of the radius will be root 2 upon 2. So I am going to write it as root 2 upon 2. That is root 2 upon 2 will become 1 by root 2. So into root 2 मैं ऊपर ही लिख देती हूँ. So now this becomes the sum. 3 minus 3 into 10 power minus वो 0 हो जाएगा मेरे लिए. और minus 5 plus 6 is just 1 into 10 power minus 8. So this is 90 root 2 volt. Right, children? If at all you want to substitute for root 2, substitute karo. But it is absolutely not necessary. You get 90 root 2. Why is it taking such a long time for you to send me the answer?
Auntie, I was solving it with like electrostatic potential of a system of four.
Electrostatic potential for a system of 4 is what I have written on the screen.
Auntie, no, I was solving it as Q1 Q2 by R1 to Q1
That is
Q3 by
electrostatic
R1.
potential energy. That is work done. W or U. This is V.
Auntie, I'm sorry, I got confused.
I honestly don't know, children. After giving the formula, if you are taking such a long time, okay, let's see. We will have another round of revision and we will see how better we can get the answer. Right? Okay. Ronak, are you still there in the class?
Yes, please.
Ananya, are you solving?
Yes, miss.
Okay, thank you. So let's move ahead. Enough of the numerical, please. You can go through similar kind of numericals, that is potential at a point, potential due to a system of charges, potential energy due to a system of charges, field force, everything in relation to system of charges. Please एक बारी अच्छे से देख लो. Now what is the next concept that we are going to do is electrostatic potential due to a dipole. इलेक्ट्रिक पोटेंशियल ड्यू टू अ डाइपोल. अगेन यहाँ पे हम डेरिवेशन पे ध्यान देंगे because we are all these are derivations in your syllabus. Okay, that's okay, Ananya. Right, so electrostatic potential due to Mayank bolo.
Sorry to interrupt, Auntie. So till now, there's just two derivations which you have mentioned, right, including
No,
this.
first तो एक derivation बोला ना पहला वाला, that is electric
Auntie, so
potential due to a point charge.
points. Yeah, Auntie. So just these two for now, right?
That is all. Okay, then we have electrostatic potential due to a dipole. This derivation has to be learnt from the point of view of your exam. Electrostatic potential at a point due to a dipole. So we know that for a considerable length of the dipole, this becomes equal to k times p cos theta divided by r square minus L square cos square theta. This is the potential at any point due to a dipole where it is a considerably bigger dipole. Is that clear? Whereas if R, the point at which you are finding the distance, is much greater than half the length, that means it becomes a short dipole, then V becomes equal to K into P cos theta divided by R square, where K is equal to 9 into 10 power 9. I am not writing the unit. That doesn't mean that K does not have a unit. Is that clear? Now, इसमें हम क्या करेंगे? We don't do like electric field where we are going to do three derivations. एक ही derivation है. Case 1 हम करेंगे if R is going to be along the axial point. So R is along the axis of the dipole. Then V becomes equal to simply the same thing, Kp by R square. Is that clear? Whereas that is V becomes inversely proportional to R square. Whereas if I am going to pick up on an equatorial point, that is R is going to be along the equatorial point, then that means V becomes equal to 0. इस कॉन्सेप्ट बेसिस पे कभी कभार एमसीक्यू में सम्स डालते हैं, तो थोड़ा ध्यान से रहो क्योंकि you are going to not calculate anything and waste your time. Any point on the equatorial line of the dipole, then the potential is going to be 0. So please bear that in your mind. This derivation with the formula for special cases and a short dipole has to be borne in mind. Any doubts so far? Please हमें बताओ. Otherwise, I am straight away moving into capacitors. A very important part. Please, आप ध्यान से. Yes. No. Okay. Thank you. Hanji, others, please take your time and let me know because it is very important what we are going to do now. We are going to talk about dielectrics. We are going to talk about capacitor, parallel plate capacitor में dielectric डालूंगी तो क्या होगा, polarization, electrostatic shielding, ये सब यहाँ आएगा. केस बेस्ड में भी पूछ सकते हैं. हाँ जी.
Auntie, is this the derivation which we use binomial theorem to solve?
Binomial theorem. Wherever we
Yes,
are
ma'am, we
applying, no,
use.
see, wherever we are applying binomial theorem and bring up a negative coefficient, I mean negative exponent, you are only going to consider the first two terms. So you don't have to worry about binomial theorem. You don't even have to mention binomial theorem in your derivation. You can simply say neglecting higher powers and expanding. That's it. You are only going to use the first two terms by bringing the exponent inside. So don't worry about NCR and NC n minus 1 into x power p into r power p minus q. कुछ लिखने की जरूरत नहीं है. You don't have to do it. That is why they have removed binomial distribution from probability also, na? For you. You don't have binomial distribution and probability also in mathematics because they don't want you to apply that theorem. So you don't have to even talk about it. Is that clear?
Yes, auntie.
Right. Chaliye, so I'm moving on to the next part, which is the most important part of this lesson, capacitance. What is capacitance? आपको जानना चाहिए. Define capacitance, the ability of a conductor to store charges. So what is my capacity to store charges is what we call as electrical capacitance, and C is going to be given by Q by V. SI unit is farad, but 1 farad is a very high quantity, so we use microfarad, which is 10 power minus 6 farad, or picofarad, which is 10 raised to the power minus 12 farad. Is that clear? Is defined as the charge required. Suppose if you have to give the mathematical definition, it is the charge required to raise the potential by 1 volt. That is what is capacitance. Is that clear? Right, children? So capacitance may you have capacitance C of a spherical conductor or C of parallel plate capacitor. So what is C of a spherical conductor? Simply 4 pi epsilon naught r, where r is the radius of the spherical conductor. So C is equal to 4 pi epsilon naught r. There is no derivation required. They have very clearly stated in the syllabus, only formula, no derivation for this and for the energy stored in a capacitor. इन दोनों के लिए डेरिवेशन की जरूरत नहीं है, सो आपको करने की भी जरूरत नहीं है. पर डेरिवेशन आप कहाँ करोगे? That is what I am going to write over here. That is going to be capacitance of a parallel plate capacitor with and without dielectric. This is the next derivation. With and without dielectric. With and without dielectric. So this derivation has to be done. Definitely derivation has to be done, where you are going to say C is equal to epsilon naught A by D without the dielectric. Yes or no, children? Without dielectric, if you are going to separate out two parallel plates, you are going to have it as epsilon naught A by D. Whereas what is going to happen if you are going to introduce a dielectric in between them? What is going to happen if a dielectric is introduced in between them, children? The capacitance C dash will become K times C. It will increase by K times because of the introducing of the parallel plate, the dielectric in between them. So you have to learn this, you have to do this derivation के साथ आप कर लो इसको. गौतम बोलो.
Miss, can you show the steps after the without dielectric to obtain the one with dielectric?
Why not? Let us derive it. Right? So C is equal to epsilon naught A by D. Now what are we going to do? We are going to pick up the parallel plates. I'm going to draw it a little bigger, but I know that these are exaggerated sizes, and you know that this is not the case in the case of the capacitor. So let this whole distance be D and this distance be T. That is the thickness of the dielectric. Okay, then with the dielectric constant K. Is that right? So here what are we going to do? I'm going to consider an electric field that is applied across the plates. Let the electric field applied be EA. Now what is going to happen when a dielectric is placed between two parallel plates that are charged? What will happen inside the dielectric? Can somebody tell me? In the chat box, what will happen? Chat box में बताइए what will happen if I place a dielectric slab between the two plates of the field? Gautam. what will happen? Thank you very much, Mayank. Yes, redistribution of charges and polarization of charges will take place. So suppose let us assume this is the direction of the applied field. So that means the field is always from positive to negative. That means this field, this plate will be positive and this will be negative. So यहाँ पे we have negative charge accumulation and यहाँ पे we have positive charge accumulation. So there is a polarization that is going to be created within the dielectric. That is, there is a field that is going to be created inside, which is going to be equal to EP. Correct? So what are we going to write? EA, the applied field, I am going to write it as sigma by epsilon naught. So what is going to happen to the polarized field? The polarized field will be the charge density due to polarization divided by epsilon naught. So what is going to be the effective field? Effective field क्या होने वाला है? E effective will be equal to the applied field minus the polarized field. So this is, sorry, this is epsilon naught 1 by epsilon naught into sigma minus sigma p. Correct, children? Yes or no? What is this? This is
Yes,
going to
ma'am.
be the net field inside the what is going to happen? This is the net field that is going to be created inside the dielectric. Now we are going to go into calculating what is going to be the potential. What is going to be the potential? There are two regions here. One in air, yeah, free space, and the other is the medium. And you know that when when two such media, this is like more in series with each other. So the effective potential will be equal to the potential across air plus the potential across the medium. Yes or no? And what is the formula we are going to use? We know E is equal to V by D. So this implies V is equal to field into distance. We are not taking the sign into consideration here because we are only worried about the magnitude of the field and not the direction of the field. So what will happen to E in air? We know that air has the applied field and the distance of the air or the thickness of the air here in our case is d minus t plus medium may I have the polarized field multiplied by the thickness T. No, not the polarized field. The polarized field or the effective field. Matlab, I will have the effective field inside the dielectric because EP will oppose EA and effectively I will have E effective. So it will have E effective into T. तो ये क्या बनेगा? E A into D minus T plus what is E effective? How can I write E effective as what is this? ये देखो sigma minus sigma p upon epsilon naught. Right, children? Now I can also write E effective as, can I write it as E applied upon K, children, where K is the dielectric constant? How did this come? Do you remember what we wrote in our previous class? What is K? F upon Fm. Right, children? Yes or no?
Yes, auntie.
So can I say Fm is equal to F upon K and F and E are directly proportional to each other. So E effective will be EA by K. So what I will write this as EA upon K into T. So EA common bahar le lo. I have D minus T plus T by K. यहाँ तक समझ में आया? So what
Yes.
happens to my V? V effective और C में क्या है? C is equal to Q by V. So what happens to the capacitance with the dielectric? Q upon EA. ये सारे डिनोमिनेटर में आएंगे D minus T plus T by K. right? I hope you are following my calculation. So what do I have over here? Q divided by EA. How am I going to write EA? इफेक्टिव फील्ड को हम कैसे लिख सकते हैं बच्चा लोग?
Miss
I'm sorry,
sigma by
applied field is
epsilon.
nothing but V into V upon D. Sorry, applied field is V upon D, right, children? Hello, Gautam, what did you say?
Miss, I said sigma by epsilon naught.
For EA, sigma by
Yes, miss.
epsilon naught, but sigma is Q by A. Okay, that also we will do. Then straight away मेरा answer आ जाएगा. So EA is equal to sigma by epsilon naught by sigma is nothing but Q upon A epsilon naught. तो Q into A epsilon naught और इसको हम क्या करेंगे? I will take it as 1 by k, t by k को अगर मैं कॉमन नहीं ऐसे ही रखेंगे and then we will put t is k. तो Q कटेगा मेरा. So this becomes equal to A epsilon naught divided by D minus T by plus T by K. Now when T is equal to D, that is when the dielectric completely fills the space between them, D minus T 0 हो जाएगा. ये D by K बनेगा. K times epsilon naught A by D बनेगा, which is K times C. Got it, beta? Got it, all of you?
Yes,
This
ma'am.
derivation
Yes,
हमें
sir.
चाहिए. दो participants. Who is that? हाँ जी, मयंक बताइए.
Auntie, I wanted to ask, Auntie, can we assume t is equal to d a bit earlier in the derivation, or we have to do it at
No,
the
no,
end?
no. This is the final derivation, actually speaking.
Okay. Oh,
And
okay.
then we
Okay.
apply it, assuming that they give you in the numerical straight away that d is equal to t, then you don't have to show it. So it will be simply
Got it.
e,
Got it.
then it will be only this, right? ये आएगा ही नहीं.
Yes, Auntie. I just thought makes it
Yeah.
easier. So
Yeah, so then there is no point in talking about the derivation. The derivation is what if I introduce a small dielectric in between them. Hanji?
Miss, can you go to the previous slide?
Yes, please. बताइए. We are not applying this because अगर मैं ये apply करूंगी फिर Q by A आएगा, QP by A dash आएगा. So all that we don't want in the formula. So I went straight into this. ठीक है? Gautam?
Yes, miss, I got it.
Yes, so after this, what are we going to do? Energy stored in a capacitor, as I told you, energy stored के लिए derivation नहीं है. So you will concentrate on numericals based on energy stored in a capacitor because they have very clearly said no derivation and only formula. So energy stored in a capacitor, the loss of energy when energy stored in a capacitor is a straight formula which is half CV square. ये मैं when we were doing alternating current also I told you half CV square. This is also equal to half. What are the other formulae? Can you put it up in the chat box if anybody knows? What is the energy stored in a capacitor apart from half CV square? There are three formulas that we write. Anybody?
Q square by C.
Correct. Half Q square by C, which is also equal to
Half QV.
half QV. Thank you very much. These are the three formulae. Depending on whatever is given to you, accordingly, you can write it. This is energy stored in a capacitor. The next one is energy density. There was one. Dheer, are you? Acha, Dheer left the class. He preferred not to stay. Okay, thank you. Energy density. That is energy stored in a capacitor per unit volume. U per unit volume, that is small u हम देते हैं. Again reference के हिसाब से ये बदलता है. This is given by half epsilon naught E square. Please इसको याद रखो, because we will do energy density due to मैग्नेटिक फील्ड एज हाफ म्यू नॉट बाई बी स्क्वायर. ये हम इलेक्ट्रोमैग्नेटिक वेव्स जब करेंगे तब करेंगे. सो दैट इज सिमिलर टू दिस. सो थोड़ा सा इसको ध्यान में रख लो. दिस इज एनर्जी डेंसिटी U विच इज हाफ एप्सिलॉन नॉट E square. And then loss of energy when capacitors are brought in combination with each other. This is again a very important concept when you are going to talk about, you know, uh, Ramachandra Prabhu's energy stored in a capacitor during combination of capacitors U minus U dash, because initial energy is always greater than the final energy. U minus U dash is greater than 0, and the formula is C1 C2 divided by 2 times C1 plus C2 into V1 minus V2 the whole square, where C1 C2 V1 V2 are the individual capacitances and potentials before the capacitors are brought in combination. So C1 C2 by 2 times C1 plus C2 into V1 minus V2 the whole square. ये जरूर याद रखना. And U1 U minus U dash is always greater than 0. This is the initial energy in the system, and this is the final energy. Some energy is lost as heat and electromagnetic radiation. Is that clear? And then one thing that you have to remember is when a system of, when a common potential, when a system of capacitors are brought, mainly for grade 12 they give you only two capacitors. The common potential is given by C1 V1 plus C2 V2 divided by C1 plus C2. This is the common potential of the system. ये जरूर याद रखो. And the common charge or the total charge will simply become equal to Q1 plus Q2. ये भी याद रखिएगा. ये दोनों याद रखिए. And the energy will become, the loss in energy will become equal to this. Is that clear? Is that clear to all of us children? This is based on energy. And the next concept is combination of capacitors. All these are from the point of view of your numerical. Please ध्यान में रखो. Again, what I'm going to write is also for numerical. Capacitors in parallel and capacitors in series. In parallel, opposite to resistors, C parallel is C1 plus C2, and in series, opposite to resistors again, 1 by Cs is equal to 1 by C1 plus 1 by C2. Again, for numerical purpose. Is that clear? Is that clear to all of you, please? This is all
Yes,
for
Aunty.
numerical purpose. And then conceptual purpose में, again I'm bringing in a few topics, polar and non-polar substances. We have done this in detail during our lesson. जब हमने lesson किया था, if somebody has been meticulous in taking notes, we have done it in detail. What are polar substances? What are non-polar substances? What is meant by dielectric? What is meant by polarizability? What is meant by polarization? What is polarization? Constant and dielectric strength. All these topics, I'm going to put it up as bullet points. What are polar? What is polarizability? What is polarizability? What is meant by dielectrics and dielectric constant? And then what is meant by susceptibility? We have done electric susceptibility also. What is meant by susceptibility? Chi. If you remember, we have also brought down the relationship between dielectric constant and susceptibility. K is equal to 1 plus chi, and susceptibility dielectric strength, it is nothing but the maximum electric field required to convert a dielectric into a conductor. That is, the polarizability will become permanent and there is an electric breakdown. We have talked about all this, children. Electric breakdown, chi, polarization, polarizability, all this हमने किया हुआ है. Polarizability is numerically equal to the surface charge density. ये सब हमने किया है. Yes. You need to know all these formulae for numerical purpose, Mayank. Is that clear? But susceptibility में numerical बहुत कम है. For capacitors, all this is only concepts. They don't ask numericals based on susceptibility in neither in magnetism nor in electrostatics. And you also have to remember E naught divided by E in medium. This is something similar to F naught divided by F in medium. Is that clear? So this is because E is equal to F by Q. So it is the same relationship. Dielectric strength is, या इन चारों में से, ये भी polarizability तो मैंने लिख दिया. इन चारों में से the more repeated is dielectric strength and the less repeated is susceptibility and polarization vector. Otherwise you need to know all this for concepts. Is that clear? What do I see here? Did we do the formula? No, cylindrical capacitor नहीं है. Cylindrical capacitor, हाँ बोलो.
Auntie, K is equal to E in medium by E naught, right?
E medium by E naught कैसे आएगा? कैसे आएगा?
Auntie,
कैसे
I thought
आएगा
that was
बोलो?
I thought that was the form.
कैसे होगा? आप बोलो. अगर मैंने E medium upon E लिखा, K is equal to E medium upon E लिखा, K is nothing but epsilon R. हैं जी? तो ये क्या बनेगा? 1 by 4 pi epsilon Q1 Q2 by R बनेगा. 1 by 4 pi epsilon naught Q1 Q2 by R बनेगा. This will become epsilon naught by epsilon. So this will give me epsilon naught as epsilon R, which is absolutely wrong.
Okay, Auntie.
Epsilon is epsilon naught epsilon R, isn't it?
Yeah, Auntie.
Yeah. Right, children? Got it, all of you? So let's do a simple numerical on capacitors. Please, Van de Graaff generator nahi hai. We don't have cylindrical capacitor. We don't have lightning arresters. ये सब हमारे syllabus में नहीं है. So please don't worry yourself by doing it. Is that clear? ये सब नहीं है हमारे. No, they are all from the point of view of JEE and NEET, not for CBSE. CBSE may we have only parallel plate capacitor and the spherical capacitor we do the formula just to know that 1 farad is quite heavy. Otherwise it is only parallel plate capacitor with and without dielectric. That's all. Is that clear? So let us do a simple numerical here. A very simple numerical. समझ लो, there are 3 capacitors C1, C2, C3 and let us say that we have a 5 microfarad here and we have a 10 microfarad here and we have a 3 microfarad here. Let us find out what is going to be the equivalent capacitance across AB. चलिए, what is going to be the equivalent capacitance across AB. This is the simplest that I can give you for combination of capacitors. हाँ जी. Okay, Pranjal, I will wait for others to send me the final answer. Somebody, no, Mayank, I don't think that is the answer, or Pranjal, I don't think that is the answer because both of you are sending me different answers. Okay, Gautam and Mayank are sending me the same answer. So, Pranjal, let us wait and see who is right and who is wrong. I will wait for a few more of you to send me an answer. Oh, Sanya sends a completely different answer. She gets 2.5. She gets 2.5 microfarad. So far I have got three answers. 3.3 microfarad, 6.3 microfarad, 2.5 microfarad, and I am getting more 6.3 microfarads. Okay, Satvika also. So let us first check. These 2 points are in series first. So 1 by CS will become equal to 1 by 5 plus 1 by 10, which is equal to 2 plus 1 by 10. So CS will become equal to 10 by 3 microfarad. Now 10 by 3 and 3 are in parallel. So I have a 10 by 3 plus 3, which is equal to 19 by 3 microfarad, which is going to be 6.33 microfarad. So Gautam and Mayank, I did not know how you got a 3.3.
Auntie, I didn't do the reciprocal for CS.
Yeah, miss, I did mental calculations. I forgot the reciprocal.
Yeah,
Thank you
same.
very much. Very well done to you. And I hope none of you were doing this and wasting your time because all of them are in microfarad. Your final answer is also going to be microfarad. So I don't think there should be any necessity to do the conversions. You can finally give it as 10 by 3 microfarad. So others, again, I did not get answers from many of you for this simple calculation. I do not know honestly if you are solving, if you are there, or if I am getting free money. So let's go into the other type. There is a 400 picofarad capacitor, parallel plate capacitor, which is charged to its full capacity using 100 volt. 100 वोल्ट लेके उसके फुल कैपेसिटी पे उसको चार्ज किया एंड देन इसको डिस्कनेक्ट करके चार्जिंग से डिस्कनेक्ट करके दे आर कनेक्टिंग another capacitor which is going to be uncharged but it is also a 400 picofarad capacitor and this is going to be connected to it. Uncharged, this is charged using 100 volt and then this is uncharged. Both are 400 picofarad capacitors. वैसे connect करने से how much of the charge is, I'm sorry, how much of the energy is lost? Energy loss कितना है? How much is the energy loss? Please calculate and let me know. I'll give you a couple of minutes. Yes, that's correct, Mayank. You have to do U minus U dash. So U is the initial energy. So let's calculate initial energy first. You are given V and C. So that means you have to use half CV square. I'm using equal to on the same line. Please don't do that in your notebook. Picofarad है. Remember यहाँ पे आपको पावर सब्सटीट्यूट करना ही करना है. तो इसको मैं 10 पावर 4 लिख देती हूँ V स्क्वायर को because it's 100 into 100. So this is 2. So 2 into 10 power. Yes, Mayank, bolo.
Auntie, since it's the same capacitor, Auntie, can't you just like calculate U dash and then do the substitution? Auntie, please say that.
Where am I substituting? I didn't do any substitution here. I first found the initial energy.
Auntie, because it just ends up being half CD square minus a quarter CD square. So it's just easier. I guess. I don't know.
Okay, let's do it. आप अपने हिसाब से करो. Let us see how we are getting it. So in order to calculate the final energy, what are we going to do? When I am going to connect these two capacitors together, what is going to be the charge? You remember we said this when we did electrostatics ka first lesson. When a charged body is going to be in conduction with an uncharged body, the transfer of charge takes place. The transfer of charge takes place till they acquire the same potential. Yes or no? Did we not say that? They attain the same potential. Till that time I am going to use that transfer of charge will take place. So that means if I am going to have Q as the total charge on the capacitor, each of them is now going to have Q by 2. Correct, children? Yes or no? Each of them will become Q by 2 because that is when it is going to be equally distributed in both of them. So the charge will become Q by 2. And what is going to be the potential that I am going to be connected? What is the potential? The potential across the charged conductor would be 100 volt. Yes or no? Because we use that. Yes, Mayank, that's absolutely right. So how are we going to do it? U final will be equal to, what is the formula? Can we straight away substitute after finding the common potential? Common potential kya tha? What was the formula that we wrote? Hanji, where is the common potential? C1 V1 plus C2 V2 divided by C1 plus C2. Now there is no V2 because the second one is not going to be connected to any potential. So I have C1 V1 divided by C1 plus C2. So what am I going to do in this case here? Since the charge is going to be U final, let me calculate. That's how my mind is working. I will calculate the common potential, which is C1 V1 plus C2 V2 divided by C1 plus C2 V2. There is no potential. So C1 is going to be 400 into 10 power minus 12 into 100 divided by 2 into 400 into 10 power minus 12. So ye katega and I have a 50 volt that is going as the common potential. So what do I have over here? I have my U final to be equal to C1 C2 divided by half into C1 into C2, C1 plus C2 sorry, into V square. तो एक कटेगा और दूसरे के लिए ये 100 बनेगा. I am getting a different answer. Where am I going wrong?
Auntie added something
No,
different.
V1 minus V2 the whole square. I am only going wrong. Why did I even? V1 minus V2 will be 100 the whole square. So that is 10 power 4 and then 10 power 6, 10 power minus 6 joule is U. So I don't even have to find out this now because I can't substitute V in the place of V1 minus V2. So I directly substituted the value. So del U will be equal to U minus U dash, which is equal to 2 into 10 power minus 6 minus 10 power, 1 into 10 power minus, initial I wrote correct, 2 into 10 power minus 6 into 10 power minus 6, 1 into 10 power minus 6. Right? Am I right? I don't have to calculate this V because I'm not finding out the individual charges also. I think ये भी करने की जरूरत नहीं है. I straight away substitute in my final formula That means I'm getting the answer. Yes or no? Am I not getting it straight away? 10 power minus 6 joule becomes my answer. So I don't have to do this. U minus U dash becomes 1 into 10 power minus 6 joule. I hope the others also did it and you got it. 1 into 10 power minus. Okay. So what we did, straight away we can do it. I actually did U initial and U final. You straight away substitute. I should not have even gone into all this, Pranavi. Go into this formula. Where is this? ये देखो, इसमें जाइए. This is what I did. C1 is 400 picofarad, C2 is 400 picofarad, 2 times C1 plus C2 is 2 times 400 picofarad, 100 minus 0, the whole square. Straight away U minus U dash becomes 1 into 10 power minus 6. समझ रहे हो?
Auntie, how do you know it's 100 minus 0 again? I didn't get
Because the
that.
second capacitor is uncharged. Now I did not connect it to any potential, did I?
Okay, now I get it.
The first one was charged to its maximum by connecting it to a 100 volt DC. But second one to uncharged capacitor tha na.
Right,
So
understood.
V2 becomes 0. C1, C2 is 400 picofarad. Directly substitute karo. 1 microjoule aa gaya. Is that clear?
Yes, Auntie.
Right, children? What about the others? So that's about it. We have touched, that's what you did, Mayank. Yes, that's what you said. But I thought I'm going to calculate the, common potential, common charge, and then go into the final energy and then subtract. I think this is the smart way of doing it. Put it directly into the equation and we get the answer. Is that clear? I don't have to do initial and final. Right, children? So we have touched all the topics in electrostatic potential. We are going to meet for a paper only on Thursday. So that means you have today, tomorrow, and Wednesday also to prepare against the test. So I am going to expect a very decent performance on Thursday from whoever is going to be there in the class on Thursday. Is that clear, children? Right? So thanks
Yes,
for joining me.